Hello, welcome to Maths with EJD. And in this second video on statistics, we'll be talking about measurement scales. So we've always seen that statistics is all about collecting data, analyzing data, and interpreting data to draw useful information for decision making, so to speak. So now, as you collect all that data, there's a way to go about measuring all of that data that you collect, and that is why measurement skills are really important. Or if you like, skills of measurement, really important in statistics. And be sure to subscribe to this channel and hit the notification bell so you can always get alerted when a new video is released. And don't forget to comment, like, and share. So let's go straight and talk about definition of measurement skills. Definition of measurement skills. Okay. Yeah. Measurement skills. Measurement skills are ways, they are ways to classify data, based on the nature, based on the nature of the data and the level of precision required. So measurement skills actually help, they help to determine how data can be analyzed mathematically. Okay. All right. So, having said that, let's look at proper, let's look at those scales and their properties. Okay. Or maybe I think I can just make a quick list of the scales. So I can just say types of measurement scales, types of measurement scales, types of measurement scales. So you have the first type, which is called the nominal scale. Nominal scale. And for nominal scale, it's actually data categorized, data categorized into groups, data categorized into groups without. Okay, let me talk about types and properties. Types and properties of measurement skills. So we can just take everything in a blow. So data categorized into groups. Data, oh, okay. Types and properties of measurement skills. So nominal scale will be, it talks about data categorized into groups without any inherent order, without any inherent order. Okay. So it is the simplest. It is the simplest scale of measurement. Nominal. It is the simplest scale of measurement. So talking about the properties, right? Talking about the properties here. So it's, first of all, no order. It has no order or ranking, no order or ranking between categories. So it's not like this is better than that. No, they are just there. Okay. The next thing is that no arithmetic operations are meaningful. No arithmetic operations, no arithmetic operations are meaningful. So you cannot find the average of two categorical data, something like that. So no arithmetic operations are meaningful. Okay. All right. So very good examples. Very good examples will be this. Like we saw before, I know it's closely linked with the idea of categorical data we explored previously. So you can talk about blood type, right? Blood type, and that would be A, B, A, B, O. Okay? These are examples of nominal. So you can't add A and B together to get and divide by two to get something, no. So, and then you have eye color. Say, so people have different eye colors. It can be blue, it can be green, it can be brown. Blue, green, brown. Okay. And of course, so much more. So the key property here, the key property of nominal scale, the key property is that it is categorical without ranking, categorical without ranking. So categorical, meaning that it's non-numerical. No ranking. You can't say A is better than B or B is better than A or something. No, there's nothing like that as far as nominal scales are concerned. So that goes. So let's talk about ordinal scale. The second type of scale is ordinal. Number two, you have ordinal scale. Ordinal scale. So for ordinal scale, right? Um, the definition is this that it is data. So in ordinal scale, data is categorized. Data is categorized into ordered groups. Ordered groups. But the differences or the differences between ranks are not meaningful. Are not meaningful or consistent. Okay. That is ordinal. So they are numerical values, right? But then the ranks are not, there's no, not a big deal. There's no, uh, the differences between ranks are not meaningful or they are not consistent. For instance, okay, now let's talk about properties, right? Like the order we've been going. So about properties of ordinal scale. So first of all, you have ordered categories. Ordered categories. Okay. Then you have no meaningful interval, no meaningful intervals between ranks. No meaningful, no meaningful intervals between ranks. Okay. And then comparison of order. So you have comparison of order, but but not of distance between values. For instance, you can say, okay, in a race, right? You have first, second, third, fourth, and things like that. Of course, the first is ahead of the second. That is why you say it is ordered, but no meaningful interval. So let's say the first person can run the race in, let's say if it's a 100-meter race. So the first person can run the race in, say, 30 seconds, and the second person actually runs it in 28 in 29.5 seconds, and the third person runs it in say uh okay, the first person is the fastest, right? So let's say the first person runs the race in 30 seconds. The second person probably runs it in 30.1 seconds. You understand? That's really close. Let's say the third person actually runs it in 40 seconds. So of course first is ahead of second, but then the intervals between them don't actually matter like that. Okay? So that is ordinal scale. Comparison of order, but not of distance between values. So the distance between values can be anything as far as ordinal scale is concerned. So talking about examples, we have something like survey. For instance, you can have survey responses. survey. So if you can make a survey and you get responses like maybe satisfied, you know. So you have a question and you just want people to show if they are satisfied with a particular thing. Somebody can even be neutral. Somebody can be neutral, or somebody can actually be dissatisfied. Another common one you see when it comes to survey responses would be something like agree, agree a bit, not neutral, agree, disagree weakly, disagree strongly, and things like that. So those are ordinal, right? So they are categorized. You can see the ranking, but there are no the intervals between them don't really matter. So you can also talk about class rankings or rankings in a race, right? So talking about class ranking, of course, you have a student that is first, you have another student that is second, you have another student that is third, and so on and so forth. But the distance between first and second is not a big deal. Like the first person can actually score 98% and the second person scores like 65% and the third person scores 62%. So the interval between the rankings don't actually matter. And that is why it is said to be ordinal. Okay. So the key property for ordinal scale, key property, we have properties, but the big deal here is actually the fact that it is categorical. It is categorical with a meaningful order. It's categorical with a meaningful order, but no consistent interval. But no consistent interval. No consistent interval. Consistent interval would have been something like, okay, the first person is scores 98. The next person should score 10 less than that. That's like 88. The third person scores 70, but you don't have power over that. That is why it is ordinal, right? So the first is better than second for sure, and the second is better than third. But the extent to which first is better than second or second is better than third is not consequential. Is not an issue in the case of ordinal scale. Okay, let's go and talk about the third type of scale, which is called the interval scale. Interval scale. Okay, for interval scale, right? Data is numerical. Data is numerical. Data is numerical with meaningful meaningful intervals between values. Meaningful intervals between values. But there is no true 0 point. But there's no true 0 point. So for interval scale now, data is numerical with meaningful intervals between values, but there is no true 0 point that you will get in a jiffy. Okay, so let's talk about the properties in this case, the properties of interval scale. First of all, you have numerical values with equal intervals, with equal intervals between measurements. Okay, equal intervals between measurements. Then you also have another property is that no true zero. No true zero simply means that the fact that you have zero does not mean that thing has ceased. Okay, it is still there. You know, so you see the examples and you'll understand better. So no true zero, right? So ratios are meaningless. So ratios are actually meaningless because there's no true zero. Meaningless. Okay. And the next thing is that addition and subtraction are possible. You can actually add or subtract here. Addition and subtraction are possible. Okay. And division are not. But okay, addition and subtraction are possible, but multiplication and division are not. Multiplication and division are not. Okay, so addition and subtraction are possible, but multiplication and division are not. Okay, examples to drive the point home. So say you have temperature in Celsius, temperature in Celsius. So in this case, right, 0 degrees. 0 degrees doesn't mean there's no temperature, right? 0 degrees does not mean the absence of temperature. Does not mean the absence of temperature. And that is what we mean by saying there's no true zero, meaning that zero, if there's true zero, that means that at 0 degrees, temperature ceases to exist. For instance, if you say someone or something is 0 meter long, it means the thing does not even exist, right? 0 meter long means it doesn't exist. But 0 degrees centigrade is actually, interestingly, I think it's 273 degrees. Uh, am I correct with that now? I think it's 32 degrees Fahrenheit or something like that. I'm not sure. But 0 degrees temperature does not mean that temperature has ceased to exist. It is still there. It is just like any other value in the process. Okay. Then you can also talk about calendar years, right? If you imagine that the year a child was born is year zero, it doesn't mean that the year has ceased to exist. Okay, it is just year zero for that particular person. So, like, say 1990 can be like your base year, and then you have 2000. So you can now say that's 10 years after. Another 10 years after 2000 is 2010, or 20 years from 1990. So if 1990 is the base year, it's like year zero, and then from there you have 10. From there you have 10. Overall, you have everything is 20. So there's no true zero. You can subtract yes, you can add yes, but multiplying them makes no sense. Absolutely no sense. Okay. And then the key property here is this. The key property, of course, just to drive the point we've mentioned it before, it is that it is numeric. Interval scale is numeric with meaningful intervals, with meaningful intervals. So when we talk of meaningful interval with temperature, for instance, you have 0 degrees, 1 degree. So the distance between 0 degree and 1 degree is the same distance between 1 degree and 2 degree. Okay, 1 degree centigrade and 2 degree centigrade. So numeric, it is, interval scale is numeric interval, with meaningful intervals actually. But the key is that no true zero. But no true zero. No true zero means the fact that you have zero doesn't mean that the thing ceases to exist at that point. Okay? And that takes us to the last kind of scale, which is called the ratio scale. That's number 4, ratio scale. Ratio scale. So as the name implies, right? We've not been able to do ratio with any of the previous scales, but here ratio comes into play. So you have data is numerical. The data here is numerical with a true 0 point. So here, when you say something is zero, it is actually zero. It doesn't exist. So data is numerical with a true 0 point. Okay. And all arithmetic operations, all arithmetic operations of addition, subtraction, multiplication, division are meaningful. Okay. So here you can do all the maths, all the arithmetic. So they are really meaningful with ratio scale. Okay. Now, what are the properties of ratio scale? Properties of ratio scale. So first property, just like we said, it actually has numeric values with a true 0 point. The true 0 point. Okay. Apart from that, we have meaningful intervals. So an interval scale has meaningful intervals. meaningful intervals, and ratios, meaningful intervals and ratios, then it actually allows all arithmetic operations. It allows all arithmetic operations, all arithmetic operations, e.g., twice as much. So you can have twice as much of something in an interval scale, or half as much. You can have that too. So in essence, we are saying that twice as much or half as much makes sense. Makes sense, actually. So you can multiply, you can divide, you can add, you can subtract. So you could only add and subtract with ratios with interval scale, but you could not multiply or divide. But here you can multiply, divide, add, subtract, and all that. Okay. So let's talk about the examples of ratio scale. So the examples, you have things like height in meters. Height in meters. So you can talk about, say, someone is 50 meters tall, and then somebody is 100 meters tall. You know, those are like possibilities now. Then you can talk about weight in kilograms. You can say somebody weighs half of someone else's weight. That makes sense. So we have weight in kilograms. Then you have time taken to complete a task. So somebody can take double the time another person takes to complete the task. Somebody can take half the time another person takes to complete the same task. Okay. So you can say time taken to complete a task. To complete a task. E.g., you have 0 seconds, you have 5 seconds, you have 10 seconds. Okay. So like that. Then the key property here is that it is numeric. Uh the ratio scale is actually numeric with a true zero, allowing full arithmetic, allowing full arithmetic. So when we say 0 second, then the time does not exist. So you can't go negative seconds, right? But in the case of temperature, you could go negative, and that is why there's really no true zero in that case. Okay. So we can summarize, right? We can just summarize everything we've done so far and say something like this. Okay, I think I'll oblige with the summary. So let's say in summary, right? We have the 4 measurement scales. We have nominal. So nominal is it's categorized with it will categorize. Categorizes data. It categorizes data without ranking. Okay. Categorizes data without ranking. Don't forget like gender, male or female, blood group, and all that. Then you can have ordinal scale. It categorizes with ranking. Okay. It categorizes with ranking, but intervals are not meaningful. Intervals are not meaningful. Okay. Then you have what you call the interval scale. Interval scale. That is actually it's numeric. It's numeric. So you can say nominal and ordinal. Okay, let me be quiet about that so I don't confuse you. So interval, so you have numeric with equal intervals. It's numeric with equal intervals. So, but no true zero. But no true zero. No true zero. Okay. So lastly, you have the ratio scale. So ratio scale is numeric. It's numeric So I think the idea of numeric is that you can actually carry out some arithmetic operations on them, but interval can only take addition and subtraction, while ratio takes addition, subtraction, multiplication, and division. So ratio scale is numeric with equal intervals, numeric with equal intervals, and a true zero, a true zero, which allows for arithmetic operations, arithmetic operations. Okay. Now, I mean, some features, right? Features from the scales that we have seen, features from the scales that really matter would be things like, first of all, you talk about ranking, okay? Ranking is something. So some interval have actually the only one without ranking is nominal. Nominal scale doesn't have cannot rank data. So for ranking now, ordinal, interval, and ratio can rank. Then the next thing after ranking is talking about intervals. Okay, intervals. So for intervals now, only interval and ratio have meaningful intervals. Interestingly, okay. I think I should go ahead and do that. Features from the scale, right? So for ranking, nominal does not rank. So ranking goes for okay, I think I can use their first letters now. Okay, no repetition. So ordinal, ordinal, interval, and ratio have ranking. So for intervals now, only interval and ratio actually have meaningful intervals. Okay. Then the next thing we talk about after uh, intervals would be something like true zeros, okay? True, true zero, true zero. So only ratio scale has true zeros. Only ratio scale has true zeros, okay? So then of course we can talk about arithmetic operations, which is connected to the idea of true zeros, right? So you have arithmetic operations, which is closely connected to true zeros. So arithmetic operations. Okay, let's do it this way. For talking about true zero now, so when there's ranking without no true zero, so you can have just addition and subtraction. But when you have true zero, you can have addition, subtraction, multiplication, and division. Okay, and it is interval scale fits in here. Interval scale works here, and then here only ratio scale features here. Ratio scale. I can take all four. Already, so for true zero now, no true zero is interval scale, right? Like we see. Okay. So that's some kind of summary. So to round it all off, we see this measurement. Okay, I want to write that because it's also important. Um, what do I call this now? Can I say conclusion or something like that? So let me just write. I just said these measurements, right? These measurement scales determine how data can be analyzed, how data can be analyzed, and what, did I say what? And what actually? These measurement scales determine how data can be analyzed and what statistical methods are appropriate for the data. So, I mean, as you go on in your statistics journey, right? When you are confronted with data, the first thing you want to see is what kind of variables do you have? What is the scale for measuring those? So the scale of measurement is going to let you know the kind of analysis you need to carry out, right? So can I just say conclusion here? I say conclusion. Okay. something like that. So this measurement skills determine how data can be analyzed and what statistical methods are appropriate for the data. So the way you analyze each kind of scale is different, and that's why it's really important. So we are going to see more of that as we go on. So with that, we've come to the end of the second video. You don't want to miss the ones coming after, so you want to subscribe to this channel. Um, hit the notification bell also so you can always get alerted when a new video is released. And don't forget to comment, like, and share. So that's how it's been today. See you next time. Bye.